Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Too Many Pigeons by Math Guy 12. And here are the rules. We have doppelganger rules, where we need to fill each cell in the main grid such that every row, column, and box contains 0 and 8 different digits from 1 through 9. No two rows, no two columns, and no two boxes may be missing the same digit. So say we're missing say we're missing a 9 here, and we are missing a 9 in row 5. You cannot have any other row be missing a 9 in the puzzle besides row 5. Same with column 5. Column 5 is missing an 8. Therefore, no other column can be missing a row at 8 in its column. And we're missing a 4 in the box 5. That means no other box can be missing a 4 in the puzzle besides box 5. For each 0 in the grid, the digits missing in its row, column, and box must be 3 different digits. So that means this 0 is missing a 4 in the box. That means you cannot have a 4 missing in its row or its column. So this cannot be 4, this cannot be 4. And whatever these digits are, they have to be different from each other too. Because this 0 must be missing 3 distinct digits. Fill each outer cell with the digits missing from the corresponding row, column, and box. So this is just a normal doppelganger with just filled in digits. So basically, I guess just a normal doppelganger puzzle. There are no other rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So again, we have 9 missing in row 5. That means it has to be in every other row. So where is 9 in row 2? It has to be one of these two. Where is 9 in row 8? Can't be here because 9 in the box. It has to be, can't be here because 9 in the column. So it must be one of these two. 9 in row 7 is one of these 6, so that's pretty broad. So is 9 in row... So 9 has to be missing in either box 4 or box 6. Because we only have 2 9s in those in rows 4, 5, and 6. Because we're missing a 9 in rows 5. I guess rows 4 and 6. We don't know if there's a 9 in box 4. It doesn't necessarily have to be. There has to be a 9 in box 5, but it's in one of these 5 cells. Oh, where's the 9 in column 5? There has to be a 9 in column 5. It cannot be here because of 9s in the rows. It cannot be here. Actually, it could be here. Never mind. I was thinking that it didn't it had to be in one of these 2 spots, but it actually could be in this spot too. So that could be 9. What about 1s? 1 could be here, but we could be missing a 1 in box 7. 1 could be here, or we could be missing a 1 in box... Oh, we're not missing a 1 in box 5. Where is the 1 in that box? It cannot be here because of 1 in the row. It can't be here because of 1 in the column. So it must be here. So this is 1. We're not missing a 1 in rows 4 through 6. 2. We have a 2, and in box 5, we're not missing it. So it cannot be here, cannot be here, cannot be here. Whereas a 2 in box 5, it has to be there. Whoops. 2. Okay, we had that. 2. 7. Remaining digits in box 5 are 5, 6, 7, 8, 9. No 6 here because of 6 in the row. No 7 here because of 7 in the column. 9 could still be any of those. We are missing a 9 in row 5, so this cannot be 9. Remaining digits of row 5, then, are 0, 4, 5, 6, 7, 8. This obviously cannot be 8 because of 8 in the column. This can't be 6 because of 6 in the column. No 7 because of 7 in the column. No 8 because of 8 in the column. No 6 because of 6 in the box. Okay. We're missing, 8 in column 5, so this cannot be 8 here. What other remaining digits in column 5? We have 0, 4, 5, 6, 7, 9. Well, this can't be 7 or 9 because 7 or 9 in the row. No 9 here because of 9 in the row. This is fine. No 7 here, no 6 here because of 7 in the box and 6 in the row. No 7 or 9 here because of 7 or 9 in the row. We are missing a 3 in row 9. We're also, we're missing a 3 in row 9 and a 3 in column 9. That means the 3 has to be missing from box 9. Because that's the only one that combines a missing 3 in row 9 and a missing 3 in column 9. So that means the remaining digits in this box, box 9, are 0, 1, 2, 4, no 5, 6, 7, 8, 9. So no 1, 2 here, no 1, 2 here because of 1, 2 in the row, no 1, 2 here, no 1, 2 here because of 1, 2 in the column, no 7 this way, no 7 here because of 7's in the column and row, no 6, 8 in the row here, and no 6, 8 in the column here, no 9 here because of 9 in the column, no 9 here because of 9 in the row. That's interesting. Okay, so we're missing a 3 in box 9. So the 0 cannot be here. And the 0 cannot be here because if the 0's here or here, it's missing a same 3 in the box and 3 in the column or row. So these cannot be 0 here. So 6 and 8 is one of these 3 digits. 7 and 9 is one of these 3 digits. 1 and 2 have to be one of these 4 digits. And 4 could be anywhere. Okay. 8 has to be missing from either box 2 or box 5 because it's missing in column 5 and it's not missing in box 5. Sorry, box 2 or box 8. Can't be missing from box 5 because 4 is missing from box 5. The missing digit in column 4 could be 1, cannot be 2, no 3. It cannot be 4 because well that means where is the 4 missing in column 4, 5, and 6? Because it must be missing in columns 4, 5, or 6 because it's missing in box 5 it has to be missing in box 6. Okay. Same with rows 4, 5, and 6. 4 cannot be missing in row 4, so it must be missing in row 6 here. Okay. Remaining digits in box 6. We have 0, 3, 4, 5, 7, 7, 8, and 9 as possibilities. 0, 3, 4, 5, 7, 8, and 9. Okay. 0 cannot be here because of 0 in the row. This cannot have 7 or 9. This cannot have 7 or 9 because of 7 or 9 in the column. No 4 here because of missing 4 is missing in the row. No 8 here because of 8 missing in the column. Or, sorry, 8 in the column. This can't be 5 because of 5 in the column. So where can... maybe we should continue. Where can 1s be? 1 cannot be here or here because of 1, 2 in the row and column. Oh, this is either 1 or 2 here, and we're missing the other 1 or 2 in box 3. Right, because 1 and 2 can't be here, 1 and 2 can't be here. Where can 1 and 2 be? And it's same with box 7, right? 1 and 2 cannot be here, 1 and 2 cannot be here. Where is 1 and 2? It has to be there, and the other 1 and 2 must be missing from there. So the remaining missing digits are 5, 6, 7, 8, 9. Obviously, 9 cannot be missing from box 1. 9 cannot be missing from box 2 and 5. 8. 8 cannot be missing from box 4 and 6. 6 cannot be missing from box 6. 7 cannot be missing from box 8. And so this has to be a 1-2 pair. So 1 or 2 is missing in columns 1, 2, or 3, or 7, 8, 9. And in rows 1, 2, 3, and rows 7, 8, 9. So this cannot be missing. So we're missing 5, 6, or 7 here. And we're missing 5, 6, or 7 here. They have to be different digits, though. Which kind of makes sense. Okay. So we're guaranteed a 1 in... So 1 has to be one of these digits in column 4. We have a 1 here. 1 has to be one of these 4 digits in box 9. We are not missing a 1 or 2 in row 8 because we have a 1 or 2 there. So this must be missing a 1 or 2 in row 7. And therefore the 0 cannot be here in row 7. Because if that's 0, that's missing the 5, 6, or 8. Which would be missing... So this has to be 5, 6, or 8 that's missing. Similarly, this can't be missing 1, 2, but this could be missing a 1. And that could be missing a 1 or 2. Remaining digits in these 3 cells and these 3 cells are going to be interesting. So what can this be? You could have 0, no 1, 2, 3, 4, no 5, no 6, and it's 7. So it's 0, 3, 4, and 7 as possibilities. What about these digits? Could be 0, no 1, 2, could be 3, 4, no 5, or 6. So 0, 3, 4, 6 there. This must be missing 1 and 2 here. So you cannot have 0 be there. because that would be missing the 1 or 2 in the box and the same 1 or 2 in the column. This has to be 5, 7, or 9 here to correspond with the missing digit in box 6. Cannot be missing 5. Okay, so this is not missing 5, therefore this can't be missing 5 because of 5 in the column. So it's missing 7 or 9 here. Huh. Okay, remaining digits in... So the remaining digits in box 3 cannot be 1 or 2. It has to be 0, 3, 4, 5, 6. Okay. This can't be 6 because of 6 in the column. These cannot be 3 because we're missing a 3 in the column. So 0 is either here or here. So only 1 out of 1 or 2 is here. But we know we have to have both 1 and 2 here, so the other 1 or 2 is here, which makes sense. Remaining digits here are 0, 3, 4, 5, 7. And this can't be 7 because of 7 in the row. This can't be 3 because we're missing 3 in the row. Okay. Let's remove these 9s because that's not helpful. Yeah, we could remove these 9s also because of the same problem. Remaining digits in box 8. We have 0, 3, 4, 5, 6, 8, 9. 0, 3, 4, 5, 6, 8, 9. No 0 here because of 0 in the column. No 9 here because of 9 in the row. No 6, 8 here because of 6, 8 in the row. No 5 here because of 5 in the row. This can't be missing a 5 in row 8 because we have a 5 already in the row. So this cannot be missing a 5. It's missing 6 or 8 here. Okay. What does this mean? That means we have to have a 5 here and a 5 here. We kind of already knew that, but okay, so this is 5 guaranteed this way. This is 5 guaranteed this way. So this digit cannot be 5. It can't be 1 or 2 or 9. So 0, 3, 4, 6, 7, 8 are possibilities, which is still pretty broad. This can't be 4 because of 4 in the column. So this 0 must be missing different digits from 5, 6, and 7. But we don't know what that is. Ah, these must be completely different 1s and 2s. Ah, very clever. These must be completely different 1s and 2s because we can only be missing a 1 or 2 one time in each box. So this digit is a 1 in one scenario and a 2 in the other scenario. So this cannot be 1 or 2 here because it sees both 1 and 2 necessarily. So this has to be 4, which makes 4, which eliminates 4 in the rest of the row and column. So no 4 here, no 4 here. And then this it could be both zeros. Could be both 5s too. That also eliminates 4 from the rest of the box. We are guaranteed a 1 or 2 in row 9. Where can they be? You cannot have it here because of 1, 2 in the column. Can't be here because of 1, 2 in the box. Can't be here because of 1, 2 in the column. So 1 is here. The other has to be here. Same with 1, 2 in column 9. We are guaranteed 2 1, 2s. Actually, I guess we have a 0, 5, 7, 9 quadruplet in column 9. So that's another way of putting it. So this cannot be 7 or 9. It's 1 or 2, which means this can't be 1 or 2. It's 0. That eliminates 0 from the rest of the box. So this becomes a 7, 9 pair here, a 6, 8 pair here. This can't be 3 because of 3 in the column. That's the reason why I didn't spot that immediately. So let's start coloring these. This we're going to mark as the red 1, 2. We'll mark this as the dark 1, 2. Therefore, we're missing red 1, 2 in box 3 and dark 1, 2 in box 7. Since this is red, this must be dark here. So here we're missing, in column 7, we're missing red 1, 2. This must be then red 1, 2, so we're missing dark 1, 2 in row 7. So these are 7 and 9. We're going to mark these as orange and medium. 7 9s. So that means we're missing orange 7 9 in column 8. Does that help us anything? Not particularly. So orange 7 9. Oh, orange 7 9. Okay, I do see something. Orange 7 9 has to be missing from either box. Well, it can't be box 3. It can't be box 6. It must be missing from box 6. Sorry, it can't be missing from box 3 or box 9. It has to be missing from box 6. So orange 7 9 cannot be here. And this can't be medium 7 9, so this can never be 7 9 here. Which means we have medium 7 9 as one of these two. But we don't know which. Same with 6 and 8, actually. So let's make this yellow and green. Since this is green 6 8, this has to be missing yellow 6 8, and this must be missing yellow 6 8. Well, this cannot be 6 or 8 because we have a 6 8 pair here. So this cannot be 6 or 8. It's 3 4 or 9. Therefore, this must be the green 6 or 8 here. Okay. Does that help anything? I don't really know. I don't know if it helps anything. Where's 2 in box 4, or specifically row 4, it has to be one of these two. Is that helpful? I don't know. 6 cannot be here or here. Huh. We're missing red 1, 2. So it has to be missing here or here. We're not sure which. Okay, what are we missing in rows 1 through 3? It's 1, 2, 5, 6, 7, 8. Obviously, we're not missing 1, 2 here. We can't be missing 2 here. Same with columns 1 through 3. We're missing 1, 2, 5, 6, 7, 8, and 9. No, this can't be 8 here. We can't be missing an 8 in column 1. So this cannot be 8 missing here. So we can't be missing 9 or 1 here because of 1 and 9 in the column. This can't be missing 8 because of 8 in the row. This is not missing 1 or 2 because of 1 or 2 in the column. Not missing 6 or 9 because of 6 or 9 in the column. Okay. Huh. I'm still not quite used to... Okay, oh, this is 0, which eliminates... Aha. We have 0 here, which eliminates 0 in the rest of the box. We now have... Or the 0 in the rest of the column. We now have a... 3, 4, 5, 8 quadruplet in box... 3, 4, 5, 8 quadruplet in box 6. That eliminates 3, 4, 5, 8 in the rest of the box. So this can't be 5. This can't be 5. Where is the 0? Can't be here, can't be here. We have to guarantee a 0, so that's 0. And this is 7, 9, and it's not the orange 7, 9. It must be the gray 7, 9 here. So this is 0 here. It's missing a 9. That eliminates 0 in the rest of the row. It's missing a 9 in the row. So it cannot be missing a 9 in the column. So all the orange 7, 9s must be 7. So this must be 7. All the dark 7, 9s must be 9. Because the 0 cannot be missing the same digit in the row as it is the box. And this 0 then means that 9 is missing from box 4. 7 is no longer missing from any of the other boxes. So we can remove orange. We can remove medium. Okay. So this 0 is missing a 3 in the column, a 9 in the row, and the 7 in the box. Okay. We are guaranteed a 5 here, which means this can't be 5 in the rest of the column. So where is the 5 in box 3? It has to be here. So this is 5, which means we're not missing a 5 in row 2. And we need to be missing a 5 in one of 1, 2, or 3. Okay, so we're missing a 7 here, which eliminates 7 from the rest of the rows that we could be missing. The 7 eliminates 7 also here. We have to be missing a 9 somewhere in one of the columns. It must be column 2. So this is 9. We know this is a 6 or 8 here. We have 2 6 or 8s, so this must be the green 6 or 8 that's missing in row 2. That means this cannot be 6 or 8 missing in row 1 and row 3. Um, what else are we missing? Okay, so we're missing a 7 here and a 5 or 6 here. Hmm. Oh, 0 cannot be here either. And no 9. So we have a 3, 4, 5 triplet. No 0 here, and this eliminates 3, 4, 5 in the rest of the row. So this can't be 3, 4, 5. It's 7 there, which eliminates 7 in the rest of the box. So this is 0, 3, 4 as triplet, which eliminates 0, 3, 4 in the rest of the row. This can't be 3, 4. It's 9. This can't be 0, so it's 5, which eliminates 5. And this can't be 5 here. Where's the 0 in box 8? It has to be here. So this is 0. Which means this is not the yellow 6-8, it's the green 6-8. And this 0 is missing an 8 in its column, so it cannot be missing an 8 in its box. So yellow has to be a 6. So yellow must be a 6. Green has to be an 8. So we're going to remove the coloring there. Okay, so this 0 is missing an 8 in the column and a 6 in the row, and 6 in the box and 3 in the row. So that leaves, we don't know what those are. This 8 eliminates 8 here. So 8 has to be one of these two digits here. Okay. This is a 6, which forces this to be missing an 8 and this to be missing a 5. So we're missing an 8 somewhere in box, okay, 2. You cannot be missing an 8 here, so this cannot be 0. 0 has to be one of these two. What are the remaining digits in this box? We have 0, 1, 3, 4, 5, 6, 7, 9. Okay, that's a lot. Okay, so no 9 here. Okay, so this can't be 9 here because of 9 in the column, so this must be 9 here. Obviously no 9 then in the rest of the box. No 1 here or 7 here because of 1 and 7 in the column. No 7 here because of 7 in the column. No 1 here because of 1 in the... Sorry, 7 in the row. No 1 in the row here. This can't be 5 because of 5 in the row. We're missing an 8 in row 2, so this can't be 8. This cannot be 0 because... these can't be 0 because of 0 in the column. So 0 again is one of these two. It's missing 4. We must be missing a 6 in column 4 because we're missing it in box 8. So this is 6, which eliminates 6 in the rest that we're missing in the rest of the columns. So no more 6 allowed in column 4. Okay. 7 cannot be here because we're missing a 7 in the row. This can't be 9 either because we have a 9 already in the row. 7 cannot be here because of 7 in the column. We're missing a 5 in box 1, so the remaining digits are 0, 3, 4, 6, 7, 8. No 8 here, or here, or here because of 8 in the columns and rows. No 6 here because of 6 in the column. No 7 here because of 7 in the column. Remaining digits in row 4. We have what? 2, 3, 4, 5, 6, and 8. Okay, this can't be 2 or 5 because 2 or 5 in the column. No 6 here because of 6 in the column. No 8 here because of 8 in the column. Remaining digits of row 6. We have a guaranteed 0, 3, 5, 7, 8, or 9. No 5 or 7 here because of no 9 because of 9. 9 cannot be in the rest of the box. No 8 here because of 8 in the column. And that's kind of done there. This cannot be 0 because it would be missing a 9 in the column and the 9 in the box. So this is 3, 8. Hmm. 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 Yeah. Not sure where things... Okay. 8 has to be one of these two digits. Oh, 8 can't be here because of 8 in the row. Well, there you go. So where is 8 in box 1? 8 cannot be here because of 8 in the column. Why can't it be here? Oh, it can't be here because of 8 in the row already. Can't be here because we're missing an 8 in row 2, so it has to be here. So this is 8, which eliminates 8 in the rest of the column, so this can't be 8, that's 3. No 3 or 8 here. That eliminates 3 from being there, and 3 from being there. Okay. So 8 has to be one of these 3 digits here, but that doesn't help us much. Huh. Okay. We know 8's there. Oh, this 8 eliminates 8 in the rest of the column, so this becomes a 3, 4, 5 triplet also, which eliminates 3, 4, 5 in the rest of the column and box, so this has to be 6, this has to be 8. That eliminates 8 in the rest of the row. This 6 eliminates 6 in the rest of the row. So now we have a 0, 4 pair in column 2, which eliminates 0, 4 in the rest of the column. So this is 6, which makes this not 6. This is 5. The 6 eliminates 6 in the rest of the box also. This 5 eliminates 5 in the rest of the row and box. So this cannot be 5 here. It's 7. This can't be 5 or 7. It's 9. So this can't be 5 or 9. It's 8, which means this can't be 5 or 8. It's 6. So 7 here eliminates 7 in the rest of the row. We now have a 4, 7, 4, 5 pair in row 5, which eliminates 4, 5 in the rest of the row. So this is 8. No more 3 here. No 3 here because of 3 in the box. So this is a 2, 4 pair, which eliminates 2 and 4 in the rest of the row. This can't be 4, it's 3. This can't be 3, it's 5. This can't be 5, it's 4. This can't be 4, it's 5. So there's no 5 or 8 here. This cannot be 3 or 5. It's a 0, 7 pair there. Right. What else do we have? So this is 7, which eliminates 7 in the rest of the column. We have a 0, 3, 4 triplet in row 2, which eliminates 0, 3, 4 in the rest of the row. This can't be 0, 3, or 4. It's 7, which eliminates 7 in the rest of the column. So this is 0, which makes this 7. And this can't be 0 or 7. So it's 3 or 4. This can't be 0 or 7. It's 3 or 4. 3, 4 pair in column 1 eliminates 3 and 4 in the rest of the column. Therefore, this is 2. This is 4. That means the red is 1. And the dark is 2. So now we can remove coloring. That means we're missing a 5 in column 1, which means we're missing a 2 in column 3. That means we must be missing... we don't have that information. So this must be a 1-5 pair that we're missing here. 3, 4, 0, 4. This cannot be 7 because of 7. And this can't be 4 because 7 in the box, 4 in the column. No 4 here. This 5 eliminates 5 here. So this is 4, which eliminates 4 in the rest of the box and column. No 4, 5 here, no 4, 5 here. So that makes this 6, which makes this 7, which eliminates 6 and 7 in the rest of the box. And the rest of the rows. So this can't be 6. We have a 0, 3, 4 triplet in box 1, which eliminates 0, 3, and 4 in the rest of the box. So this is 6. These cannot be 6 anymore. This is 0, 3, and 4. This is if a 0 were here, it would be missing a 2 in the column and a 2 in the box, which is not allowed. So this can't be 0. This is 3, which makes this 4, which makes that 0, which makes this 4, which makes that 3, which makes that 0. That eliminates 0 in the rest of the row. This 0 is missing a 5 in the box, so it cannot be missing a 5 in the row. So this is 1. This is 5. That eliminates 1 in the rest of the row. Because we can't have a 1 in row 1. We can't have a 5 in row 5. We also have a 3, 4, 5 triplet in box 2, which eliminates 3, 4, 5 in the rest of the box. 4 eliminates 4 here, so this is 3. This can't be 3 or 4, it's 0. 3 eliminates 3 here, so this becomes a 4, 5 pair, which eliminates 4, 5 in the rest of the row, so this is 3. This can't be 3, that's 4. This cannot be... This 4, 5 eliminate, and 3 eliminates 3, 4, 5 in the rest of the box, so that's 1. This is 0. 3 here eliminates 3 here, so it's 5 and 3. 5 here eliminates 5 in the rest of the column, so this is 4 and 5. And that's how you solve it. Very cool use of doppelganger Sudoku to limit things. Very interesting. Like, just basically how the doppelganger works just as a plain, like, puzzle with just the doppelganger rule set. Yeah, fascinating. You have multiple possibilities of basically eliminating things based off of where they can be missing. So... Very cool. Oh, I guess this is... Yeah, and this is actually... Too many pigeons is a reference to the pigeonhole principle. Where basically, there's only so many... I don't exactly recall how... I'm not quite sure why it's called the pigeonhole principle. It's something to do with, like, you can only put so many pigeons in each... You have a certain amount of holes. And you have too many pigeons. So you have, like, usually it's, I think, one more pigeon than you have holes. So you can only put pigeons in each hole, one pigeon per hole. That means you're left over with a pigeon outside of a hole, which I guess is essentially similar to these, like, 1-2 pairs, right? 1 and 2 can only be in one spot. So the leftover 1 or 2, which is the leftover the pigeon, means that you have to exclude that from the box, right? And that's why it's called too many pigeons, because we have, in these scenarios, too many pigeons for the pigeonholes that we have. We only have one hole, and we have 2 pigeons to try to stuff into there, which is not allowed. So, yeah, it's called the pigeonhole principle. I don't remember actually. I think we do use that principle a lot in normal Sudoku. And it's even more, I guess, in the doppelganger because of the way that it works here. But anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.